Hello, everyone. Welcome to the ECS 179 Gameplay Programming Exercise 3 review. This exercise is about the factory design pattern. I'll be releasing information about the factory design pattern alongside this material for exercise 3. So you can have an idea of what the factory pattern entails and how to construct it and make it work in this game project. For now, we're going to review the project itself and look at the files and how this project is constructed. Then we will go over the syllabus and assignment description for exercise 3. Let's get started. So first, this is the Aegis project. It is the main project that you will find in the exercise 3 template, the automatically generated repository for you on GitHub Classroom. So when you open it up, you should see something roughly like this. Now, this file, this world, consists of a scene called world. So we have our scenes nodes, world. The one in blue here is the one that we load by default when we press play. So world consists of a laboratory. This laboratory is itself a scene that holds the major components of gameplay. The weapon apparatus, the shield apparatus, the surveillance equipment, which is a set of cameras and lights in the world, the structure, which is the box the test app, all the laboratory sits in, and a sound system. All right, to be clear, surveillance has 4 spotlights and 4 cameras. And the structure has north wall, south, east, west, 4 walls, and an up wall and a down wall, also known as a floor and a ceiling. Now, we have a few constituent parts here. So the weapon apparatus is its own scene consisting of this T-shaped weapon mount point that fires projectiles. It has a stand, it has a barrel, it has a point at which projectiles are spawned and shot, and it has a collision surface. The shield apparatus consists of a pedestal, a tiny generator, which is the physical representation of the thing that generates the shield. We have our shield mesh, which itself is an interesting component. It is a icosphere, so you can find that actual sphere in the assets. The sphere.obj is that sphere with the made of the flat hexagons. We have a collision shape, which is the exact same size as the shield mesh. And we have a damage indicator spawn point, and we'll see what that is in a moment. The shield mesh has a script attached to it that helps change the color of the shield. So you'll be interfacing with this a little bit. This is also a shader from godotshaders.com, the Energy Shield with Impact Effect shader. And it allows us to have this neat shader graphics effect, which you can see previewed here, where you can go inside the material. You'll see that this is the energy shield.gd shader, and this is in our shaders folder, energy shield.gd shader, and it is a shader file. You can see the shader code here, and you can see all of the variables that the shield exposes. So if you want to change the color of the shield, you can here. Do a color picker. You can change its intensity and color, brightness. And so some basic shield things. What's important here is that you'll see that the weapon shoots projectiles. So we have a projectile scene, which is simply a projectile. We are using green colors in this project to denote something that is currently unparameterized. So if you see green in your project and you didn't change the colors in the project that are part of the gameplay to green, there's probably something wrong. All right, so this projectile has a body and a collision shape. The collision shape is spherical, the body is a capsule, and we have an acceleration parameter to show how fast the projectile accelerates when shot from the weapon mount point. All right, so let's take a look here. Now that you have the basic, the high level, the most important bits of the project known, let's take a look at how it runs and works. I will play it without commenting so you can see the default state, and then we'll dig into some more of the details.
Initialized. Open fire. Warning. Proceed. Stand clear. I thought you were smarter than this. Resistance is futile. Proceed. Shield down. Engage. Danger.
All right, so you saw a demo here of this shield test factory. I was pressing UI accept in the case UI accept action. In this case, it was spacebar on my keyboard, and that interacted with the weapon apparatus. We have the laboratory here picking up UI accept commands and calling weapon.fire. So weapon is a link to the shield apparatus, a reference to the shield apparatus node, and we're calling its fire method. So the fire method takes a defect type, which we'll look at, and a damage, instantiates a new projectile. So we get projectile as a packed scene. We instantiate it as the projectile class, which is the script associated with the base of that instance. We set the projectile to have a damage value, to have a type, and we add it as a child to the project spawn node, which was this point, this node 3D without a graphic, this point in space. All right, so we have our projectile. The projectile has a script. So we can parameterize how much damage the projectile does by default, its type, and there are 3 types, and this applies to the shields and the projectiles: kinetic, energy, and arcane. And that'll become important as the project description becomes more in sight. It has effect, acceleration curve, which is the acceleration of the bullet. As you can see, it starts out slow and then ramps up quickly. It has a speed, so we can speed up the entire projectile by changing its speed value. We're getting reference to its body. When it's ready, what we're doing is keeping track of time, getting track of its material, setting the material color to being something appropriate to the type. And we'll get into the actual implementation of that momentarily. We set the material back to the material override of the body to make that new color go into effect. And we emit a signal that says, hey, we fired. Other things will listen to the signal, and we'll take a look at the signal apparatus as well. Now we are counting up elapsed time, accelerating, moving in negative x direction based on this animation curve times speed. And then we have a collider. So when the projectile overlaps with the shield, this function is called. And so we will emit a signal that's saying, hey, the shield's been hit. And the shield that has been hit is this particular shield. And the thing that hit it was self, this particular projectile. Then we get rid of the projectile. All right. Let's take a look at the weapon one more time. So here, our weapon class has a fire. So we're just making that new projectile. We're giving damage, we're giving its type, and we're spawning it. So everything the projectile needs to do is given right here: a type and a damage value. We also have the shield itself. Now, the shield is similar. It has a type, which is kinetic by default. It also has a maximum capacity, which is the maximum damage a shield can take. It has a recharge rate. It has a recharge delay. And it has the damage effect. So if you notice when the shield gets hit,
Engage.
It shrinks over a period of time.
Exterminate.
And the amount of time it takes to shrink from one value to another is denoted by this curve. So that shrinking happens over 2/3 of a second and shrinks at this rate. All right, the laboratory has a sound system. Which consists of environmental sounds, and all of these are audio 3D streams with playlists and randomizers. And SADOS, which is the noise. Instead of GLaDOS, it's SADOS, which is our robot commenter, our companion through this journey of discovery with shields and weapons. And you can look at all of these here. You can see the playlists of SADOS, all of the things that SADOS can say, all the options are denoted in this random playlist array. So there are, roughly 22 different call outs when you fire that SADOS can say. And we have some for when the shield is damaged and when the shield is down. We also have standard sound effects for when a generic firing of a weapon, when shield is damaged, when a kinetic projectile is fired, energy projectile is fired, arcane. We have noises when the spotlight is on and a noise for when the shield goes down. So this is a large bank of all of our sound effects. And those sounds are played based on signals. So when we receive a signal that the weapon is fired, we call the on projectile fire. Same with damage, on damage, spotlight on with on spotlight on, and shield down with on shield down. So on projectile fire, we actually track. It takes as a parameter the type of projectile that was fired, whether it's kinetic, energy, or arcane, and it plays the appropriate sound stream, audio stream player contextually. And then on damage, every time the shield gets damaged, we don't have SADOS say something, only 25% of the time randomly. And then we have a spotlight on noise, which you hear when the game starts up. You'll hear chunk, 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 which is the 4 spotlights turning on. So these noises are played. The spotlight turning on is triggered by the stagger activate node, which I created once and then applied to each one of the spotlights, and then changed their parameterization. So you see there is a activation delay on each of the spotlights: south, east, west, and north. That's a fairly simple script with a timer. On ready, we set the spotlights to false, and then we start delay, which means that we start a timer that matches this delay. When the timer is done, we then say, hey, the spotlight should become visible, and the spotlight is on, and we emit a signal which the sound system picks up and plays. All right, now there are a few interesting things here. So far we've seen the world, which holds the laboratory. We've seen the laboratory, world, laboratory. We've seen the shield. We've seen the weapon, and we've seen projectile. The sound system is also its own scene, which is placed in the laboratory right here. Ignore the splash screen. That should have been deleted and removed. Now we have the damage indicator, which is the last scene we haven't seen. And this damage indicator is simply a number that then moves from the origin, local origin, to this end location. And it moves from the origin to the end location according to this curve. And it moves from the beginning, or 0 of the origin, mapping toward that endpoint. So going from 0% of the way to the endpoint to all the way to the endpoint of 1. So 0 at the endpoint all the way to being at the endpoint, which is 1. It does that over this normalized time space, which we map to 1 second. Just like linear interpolation that we talked about earlier, this curve is mapping from 0 to 1 and how we traverse that 0 to 1 space over this second. And to see that in action, you'll see a number when the projectile hits the shield. You'll see a number appear near the generator and then fly towards the right.
Exterminate. Launch.
And notice that the color of
Open fire.
the damage indicator matches the color of the projectile. And that is called, in the shield, on shield hit. So this is when the projectile hits the shield. On shield hit listens to the shield hit signal and calls this on shield hit method, which then is past the shield and a projectile. We do several things here. What we're doing is we are managing the damage level, making sure it doesn't go below a minimum or over a maximum in some way. We're seeing how much the value really changed. So if the damage of the projectile was greater than the damage remaining of the shield, the actual damage is not the damage of the projectile, but the remaining capacity that was in the shield, the remaining level of the shield. So what we do here is we make a new damage indicator. So we take that damage indicator scene, which is passed in, we instantiate it as a damage indicator, and we set the damage indicator's color to be the color of the projectile. We set its displayed damage value to be damage delta, and we add it as a child to the generator. So it starts at the generator and moves to that end point in its own scene. All right, and to continue on here, we start a timer that is responsible for managing the shrinking of the scale. So the change of the scale when something is hit, let's say it takes 15 points of damage and it had 80 points, it would shrink from 80% size in its capacity, since its original size of 100, down to 65% of its capacity over 2/3 of a second on this curve. So that's how we're managing this. We emit a signal when it's damaged, the sound system can take over. We also check to see when the current level is 0 and the previous current level is not 0, so we know exactly when the shield has went down completely, has broken, and we emit a signal accordingly. The rest of the scale logic is in process. I'll leave that for you to check out and understand. I'm happy to answer questions about that later, but we want to manage the scale over time. The last things we want to look at here are the effects.gd. So this is one of our auto-loaded scripts, meaning this script is set to run outside of the tree node structure when the project is started. So you can think of this kind of as a global, kind of as a singleton. It's got that is present no matter what is on the tree attribute, that quality. So here we have a new class name called effects. It extends node, so it can be on the scene if we need it to be, and it has an enum. This enum is the various types that we have in the system. So kinetic, energy, and arcane are our shield and our weapon types. And we want to make sure that we have a color associated with each type. So you can see here we have effects colors, and we have these stored as resources. So we'll unpack that in just a moment. We have a function here that then takes different colors that finds the color of a particular type given the color resource and returns that color. Now, these are resources. Colors can be resources. Well, they can be, and you can see them right here. Arcane color, energy color, and kinetic color. So here, the kinetic color is blue. The energy color is this yellow, and arcane is this pinkish lavender color. Now we make this ourselves. You can make custom resources in Godot, which is very handy. The custom resource is a class that's just simple script called effect color, and it extends the resource class. And we export variables of effects and color. So now what you can do if you have one of these scripts defined and placed in your project, you can create new resource. So I guess you can't quite see that. But you can create a new resource of type effect color and add it into the tree. So here you, because I'm screen capping just Godot, I right click, the very top option is create new, and it has an arrow to the right, which has other options. The fourth option down is resource. I'm clicking that. And then you get one of these create new resource trees where you could type in the search effect color, and you would get a new effect color. You can save it as a new resource, give it a new name, and it ends up being a file. And so I just made a new one right here, and it has got the default value. So we can set energy here to be red, some sort of brickish red color if we wanted to. And we can have alternate colors for the different resources if we wanted to. So let me delete this. So these static resources are very handy ways to have saved data. They're ways that designers can have an instance of a class inside of a resource tree and drag and drop and use it if they need. These are very similar to scriptable objects in Unity. All right, so we have our effects and color system. So if you go into the project settings, and you go to globals, let's see if I can check this out. You'll see settings, effects, and signals. These are two scripts, effects.gd and signals.gd, that I have loaded in globals auto load, which means they are present when the game starts and are present no matter, they're not associated with the node. They're sort of next to the tree, so you can access them in all of your script files. So let me cache out here resources. You could create a new resource. You could have it, effect color, and then here is our new resource. You can make effect color.gd. We create a new one, new resource, boom. Okay, so we have our colors. We have our effects. One thing we haven't looked at is the signals. So far we've just been using these signals. But these signals it's a very simple mechanism. So we declare this as a global signal manager, or signal bus, as some folks like to call it. And so what we have here is a class name that we call signals. That defines the signal shield hit, damage, fire, spotlight on, and shield down. Some of these signals mandate parameters, such as the shield and projectile for when the shield is hit, or that when something is damaged, we want to know how much damage was done and what type the damage was of. And when we fire, we want to know what fire effect we have so we can play the appropriate sound. So here we have signals that, once again, are then caught up in a few places, most prominently in the sound script. Now notice that this is lowercase s signals. That is because in our project, our globals, you can load the scripts and you can also give it a name. So it makes like a node that's out of the tree, a node that you can't remove easily, that's not part of the tree apparatus, that you can then reference at any point in your code. They're like global nodes. And we are accessing such a global node here when we want to reference particular signals and connect to them. So I'm showing you as part of this project, some development patterns that will make making your games easier. These global scripts are one of those. But as with all global type things, you want to use them judiciously. And you want to be very thoughtful when you implement them. All right, so that's the basics of the project. You've about seen it all. You've seen the laboratory. You've seen the weapon apparatus, the shield apparatus, the surveillance equipment, the lights with their stagger activation. You've seen the structure, you've seen the sound system. So all the points here are sort of revealed to you. You'll want to play with this project and get a feel for what they are, how they work together, how they mesh. This one explanation I'm giving you is great, but you need to pair it with experience and play. So a few things to look at in the assets tree. I have a lot of audio files. So these are sound effects. This is a railgun noise that shoots with the energy when kinetic weapons are used. This is an energy launch for when energy weapons are launched, and explode for when the shield goes down, etc. So you can see all these. There's even like a very dramatic effects, right? There's things in here I haven't used. And I put in a whole bunch of robotic voices that I didn't use in case you want to have fun with them.
Computing. Electromagnetic magnetic pulse.
We did use this one, but I like it.
I thought you were smarter than this. Recharging batteries. Repairs completed. Resistance is futile.
So you can augment the sound system to add in more of these if you'd like. Particularly when you're dealing with some of the stages and dealing with more shield functionality, you can then add in sound effects appropriate to that functionality if you so choose. Okay, let's look at the project description. Now that you've seen the project in detail and we've seen it in action, lights coming on,
Warning.
projectiles being spawned and sent.
Proceed. Resistance is futile. Damage.
Shield checking.
Fire.
And so you'll note that during the fire call from the weapon pedestal,
Engage. Sorry.
it randomizes the type of the projectile right before the
Proceed. I thought you were smarter than this. Launched. Engage. Destroy open fire.
And it does 0 damage
Initiated.
after the shield is down.
Yes. Warning.
The projectiles are sort of wasted. They hit the generator and dissipate. All right, let's go to the browser, the exercise description. So you will receive a Google Classroom link. You will get a copy of this repository with this description with the code files that we have just looked at. So here is the base repository, the template repository. So it is github.com/dr-jam/factory exercise. And you can see the latest and greatest version of it here. Bug fixes will happen here, etc. So here is the description of this exercise. So your goal is to gain experience with the factory software design pattern. You're to create a significant portion of these gameplay programming systems from scratch or with light outlines. And I want you to implement damage tables and equations as given by designers, aka me, giving it to you here in this document. Once again, 70 points. Stage 1 is worth 15, 2 is worth 15, 3 is broken up into 2 parts, so 3.1 is worth 15, 3.2 is worth 10, and 4 is worth 15 points for a total of 70. The remaining 30 points are for your peer review and other student submission, as always. All right, and so you can look at this. This is just a light description of what's going on in the scene. This is a small textual recap of the longer in-editor explanation that we just participated in. So first, Shields Online. The Aegis prototype shield mechanism is nearly complete. Your task is to complete the shield's functionality by adding a recharging mechanism which consists of A recharge rate and recharge delay, or use the recharge rate and recharge delay properties of the shield class to enable the following things. After the shield has taken damage and is not at maximum capacity, so its current level is not its maximum, it should enter a recharge delay period lasting recharge delay seconds. So it'll just take a while before it does nothing. When that recharge period has ended, the recharge delay period is ended, the shield will begin to increase its capacity at recharge rate capacity points per second. If the shield is damaged before it is fully recharged, the shield stops recharging and enters another recharge delay period. So these are kind of like Halo shields if you've played that franchise. Also, like Borderlands. That was probably more apropos. I'm probably more familiar with the Borderlands shields than Halo. So if you played Borderlands 2, these are the shields for you. If the shield cannot recharge greater than its maximum capacity and value, and the shield current level can never be negative. There's no such thing as a negative capacity shield in this world. So you were to implement those. So this is a sketch. So you would go into shield.gd. I already gave you the recharge rate and recharge delay variables. They are exported. You can see them in the editor itself. So if we go to shield, you'll see inside of shield, there's capacity, recharge rate, recharge delay, all ready for you to use. Stage 2, the damage engine. So you need to make a damage engine class, which I also recommend you auto load it just like signals and sound. And it should implement this type damage factor table. This is just like the Pokemon damage type table, where you have the projectile type on the left, kinetic energy and arcane, and the shield type, kinetic energy and arcane. Now, if the projectile type is kinetic and hits its kinetic shield, it does a factor of 1 damage, so it does the stated damage. If a kinetic projectile hits an energy shield, it does half damage. If it is an arcane shield, it does double damage. And so arcane energy projectile hits kinetic shield, does double damage, normal damage to energy shields, and half to arcane. And arcane projectiles are weak, don't do as much damage versus kinetic shields, are strong against energy shields, and are of normal effectiveness to arcane shields. So I want you to insert that damage into every time a projectile hits a shield. It should consult this table. It should consult the damage engine to find the damage that is done. All right, stage 3, factories and specifications. Here is where the factory pattern kicks in. Your task is to create 2 factories, one that generates shields, so a shield generation factory, and projectiles with a projectile generation factory. These generated items should be instantiated as nodes. So basically, you can repurpose the shield. You can delete the scenes that exist and reinstantiate them. So you can delete the shield scene and reinstantiate it with a new shield. You can delete the projectile that's there. That's really not a big deal because it usually just deletes itself after it hits a shield. And you want to make new versions of these when you need them. So when you want to regenerate a new shield, you can either make a new version of the shield scene with altered properties in the shield.gd inside of its class, or you can, and this is a more efficient way, for shields, not for projectiles, but just for shields, you can simply reset all the values in that shield that is already existing there as a generator. So you can, is existing there as an instance of a scene. So you can just reset all the values in it, make sure everything is back to a fresh state. And so your shield factory can then, it's more of a factory that retools the existing shield rather than creating entire new ones. All right, so a shield factory and projectile factories are used the factory design pattern. You will need to create a shield spec and a projectile spec. So because there are various parameters such as maximum capacity, recharge rate, recharge delay, and type for shields, and for projectiles, there's damage and type. Uh, you need you can make a projectile that has any amount of damage with any of the types. Same way as shields, you can have a large range of maximum capacities, recharge rate, recharge delays, and then the 3 types. So these specs are markers. They're writing down they're one particular configuration within that configuration space. So these are data classes and they have no methods. We're just passing data around with shield spec and projectile spec. So your factory's build function should take a specification class, an instance of shield spec or an instance of projectile spec, and they should make a new projectile according to that spec, or make or refresh the shield based on the shield spec. And furthermore, your factory should be able to generate random shields and generate random projectiles. So basically, without taking a specification, a shield spec or a projectile spec, create a random shield with a random capacity, random recharge rate, random delay, and random type. And below also give you the ranges of those types. So they're not just whatever float can represent. We will bound them. Same way with projectiles. So here are the specification ranges for random. Capacity between 50 and 250, recharge delay between half a second and 5 seconds, recharge rate between 1 capacity to 25 capacity per second, and the 3 types. Projectile specifications 1 to 50. We can ignore charge time for the charge time is sort of the acceleration time in the projectile parameter. I'll make a statement out and make that a little more clear. I forgot to change the specification on that. And of type kinetic energy or arcane. So you need to make a factory. It should take specifications, and you should be able to generate random specifications. And you can test this. I would add into the laboratory some key presses. S for shield, like A for projectile. So when you press those, you should get a new random shield. Like press S, it'll make a new random shield specification and make a new shield based on that specification. And if you press A, it will generate and instantiate a specification for the projectile and make a projectile based on that and fly it and shoot it at the shield. Stage 3.2, power underwhelming. Unfortunately, your factories are also limited in the quality of shields and projectiles they can produce. Shields are limited to a power rating of 300, while projectiles are limited to a rating of 100. The following functions determine power ratings. So the shield's power rating is determined by this function. It's max capacity plus 5 minus recharge delay times 5 plus recharge rate times recharge rate divided by 2. So that's how you get a shield rating. And if you produce a random configuration that goes above 300 rating, you can't make that, so you'll have to regenerate. You'll have to try again. The projectile rating is damage times 2 plus 3 minus charge time to the 4th power. So charge time is the thing that increases exponentially. The higher the charge time, or the lower the charge time, the higher the projectile rating is. Projective rating. Okay, I will fix this typo and this typo. Your factory should not produce shields or projectiles that are higher than the stated limits of ratings. Basically restating what I just said. All right, stage 4, still alive. So this is a Portal reference, and here's a quote from it. Because I will post the video on YouTube, I will not click on this link, which is to the Portal song by Jonathan Coulton. So in the grand tradition of automation and ever-increasing abstraction, this stage tasks you with creating a test factory that tests the output of factories. Your test factory build method should create the following: a shield specification, and then 5 to 10 projectile specifications. So then it should instantiate the shield, and then it should fire the 5 to 10 projectiles in sequence after it. So note you have that damage signal. Once the damage signal is sent, that means your projectile has collided with the shield and disappeared. That means you can start the next projectile in this list of 5 to 10 projectiles that you create. First one hits, make the second one go. A test schedule that is capable of firing all projectiles in sequential order while respecting their charge times. So the test sequence should hold the sequence order of those projectiles and should have the capability of firing them in sequence. So you need to set up the generated shield and set up the test sequence to fire the projectiles in the scene, and then run the test by shooting those projectiles accordingly. And you should report failure and huge success with appropriate fanfare. I leave that up to you to interpret. All right, so that is the full description of this assignment. It will be due a week after I send it out to you. So it will probably be due sometime next Friday. I should be sending this out on Friday, maybe a little closer to the evening than to the afternoon, like I would have planned. But there is a lot of, I think, interesting surface for you to dig into with this project. I think you're going to have a good amount of fun and learn quite a bit with it. And this one is our last project, so it's our last exercise, so it's a little less hands-on than the previous ones have been. But we have office hours and other class resources such as the Discord server to help you move your way through this project. All right. And as always, if you have any questions, feel free to contact the instruction team or ask on Discord, and we'll be happy to help you. All right. Good luck. Have fun.